this lesson we're going to be doing Euclidean geometry. A, B, C, D, E, and F. A, B, C, D, E, and F are points on the circumference of the second. ED is parallel to FC, and AD is parallel to FE. DA is perpendicular to FB. FC intersects DA at G and DB at H. Okay, let's go through it again. A, B, C, D, E, and F are points on the circumference of the second. ED is parallel to FC. These two lines are parallel. And AD is parallel to FE. AD is parallel to FE. DA is perpendicular to FB. FC intersects G. FC intersects DA at G, and DB intersects DB, and DA intersects DB at H. And then they're saying let E angle DF, that is D1, equal X, and A angle DF, that is D2, equal Y. So if that is the case, prove that angle B is equal to X plus Y, angle H1 is equal to 90 degrees. Now with Euclidean geometry, more especially when you are dealing with with circles, what you should check is the DRCPT first. You read the statement and see if between these five, which one do you have? So D for diameter, we've never heard about any center or any diameter, so we don't have a diameter. R for radius, we've never heard of any radius or of any line that is from the center to a point on the circumference of the second, so we don't have a radius. And then C, it's for cyclic quadrilaterals. So A, B, C, D, E, and F are points on the circumference of the second, so we have a chance of getting what? A cyclic quadrilateral there. And then in P is for parallel lines as well as perpendicular lines, so I give it 2 ticks. And then T, obviously T, we are going to have it, it's for triangles as well as tangents, but I'm giving it 1 tick because I've never heard of any tangent, but I'm sure that somehow I'm going to get a triangle in that diagram. Alright, let's look at it. I said I'm circling C because there is a chance there that I'm going to get a cyclic quadrilateral. Why? Although all these vertices mentioned above, they are on the circumference of the second. Now let's check. Where do we get a cyclic quadrilateral? D, E, F, B. Or you can say B, D, E, F. You can see 4 vertices on the circumference of a second, making it a cyclic quadrilateral. So we are going to look at all the theorems concerning a cyclic quadrilateral. What do we know is that the opposite angles are supplementary. That is what we know. Opposite angles are supplementary, and then in case if we have a bow tie, then the angles subtended by the same arc or chord at the circumference of the circle, they are equal in size. And then lastly, the exterior angle is equal to the interior opposite. So firstly, the opposite angles are supplementary. Secondly, the exterior angle is equal to the interior opposite angle. And then lastly, angles in the same segment are equal, or angles subtended by the same arc of chord at the circumference of the circle, they are equal. So between these three, we are going to check which one is made by that given cyclic quadrilateral. Alright. Then we are also going to look at parallel lines. So where parallel lines are concerned, what we know is that where parallel lines are concerned, what we know is that we can check FUN. F for corresponding angles, U for co-interior angles, and then lastly N for alternating angles. So we are going to check between these two parallel lines which one is made by what we have. Alright. Yeah, I think that information is more than enough. We can look at the diagram. We can look at the diagram, or we can try to answer the questions. All right. And then, before I can go to the questions, also on triangles, one thing that we know about triangles is that the angles interior are supplementary. The angles interior are supplementary. The exterior angle equal the sum of two interior opposite angles. So we are going to check which one again is made where triangles are concerned. So they are saying we must prove that angle B is equal to x plus y. We are to prove that angle B is equal to x plus y. We are given that DE is parallel to FC. So if DE is parallel to FC, then it means that if angle D1 is equal to x, so this forms a Z shape. It means that the angle here is equal to the angle here. So we can say angle D1 will be equal to angle F2. And again we have another parallel lines forming what? A Z shape. So angle D2 will be equal to angle F1. So if D2 is Y, angle F1 will also be equal to Y. These are alternating angles. So to prove the first question, this is what we can say. Angle F1 is equal to Y, and then we are saying these are alternate angles. And then since EF is parallel to AD, or since AD is parallel to FE, AD parallel to FE. And then now that we have this angle and this angle in that triangle, we can find the size of angle E. Remember, BDEF is a cyclic quadrilateral. So if it is a cyclic quadrilateral, the opposite angles, they add up to 180 degrees. So if I can manage to get angle E in terms of X and Y, then it will be easy for me to find angle B. So F1 equal to 90 degrees. The alternating angles, since AD is parallel to FE. Now let me go to angle E. From the sum of angles in a triangle, I know that E plus F1 plus D1 equal to 180 degrees. So angle E plus angle D1, which is X, plus angle F1, which is Y, equal to 180 degrees. These are interior angles of a triangle. These are interior angles of a triangle. So from here I'm going to transpose X plus Y to the other side. Angle E will be equal to 180 degrees minus X minus Y. That is the size of angle E. That is the size of angle E. Alright. Let's continue. I got angle E in terms of X and Y. Now I'm going to B, knowing that E plus B equal to 180 degrees. So I'm going to say angle B plus angle E. And what is angle E? It's 180 degrees minus X minus Y equal to 180 degrees. Then I give a reason to say opposite angles of a cyclic quad. These are opposite angles of a cyclic quad. So the 180 will cancel with the 180 on the other side of the equal sign. So this 180 will cancel with that one. I transpose minus X minus Y. So angle B will be equal to X plus Y. Someone is asking, why does the 180 cancel with the other 180 on the other equal on the other side of the equal sign? This is why. If I have B plus 180 degrees minus X minus Y equal to 180 degrees, when I transpose everything 180 minus X minus Y to the other side, I'm going to have angle B equal to 180 degrees, this 180 degrees, and then when this one crosses the equal sign, it changes the sign to minus. These two will also change signs from minus to plus, and then 180 minus 180 will give us 0, leaving us with B is equal to X plus Y. And then that is how the 180 cancels with the 180 on the other side of the equal sign. Alright, let's go to 1.2. Let's go to 1.2. They are saying we must prove that angle H1, this angle here, is equal to 90 degrees. Alright, this is what I can say. We have parallel lines giving us angle F2 as X is equal to angle D1 equal to X. So this angle here is X. So I can say angle F2 is equal to X. Then I say alternating angles, since what? Since EF, where is EF? Since AD is parallel to FE. Is it? Right here, it must be that ED is parallel to FC. Let me fix it. ED is parallel to FC, and then here I'm going to say since AD is parallel to FE. AD is parallel to FE. Remember, we have two parallel lines. We have four parallel lines. We have this one, we have these ones. So here is ED parallel to FC, AD parallel to FE. And then now that I have the size of this angle, which is X plus Y, and I still have parallel lines. So X plus Y will be equal to angle G3. Angle G3 will be equal to angle Fy. I have parallel lines. So corresponding angles. This angle here, which is x plus y, or let me put it this way. This angle here, which is x plus y, will be equal to that angle, which is angle G. It will be equal to angle G3. So F2 equal to x. Then we are going to say angle G3 will be equal to angle F1 plus angle F2. So that will give us x plus y. Angle G3 is equal to x plus y. Why are we saying this? These are corresponding angles. We are saying corresponding angles since AD is parallel to EF. AD is parallel to EF. And then if we have G3 as x plus y, then it means that if we have G3 as x plus y, then what does that mean? What does that mean? Okay, the idea here is me finding angle H1. Or it's me showing that angle H1 is 90 degrees. So I have angle G3 as x plus y. Now I know angles on a straight line are supplementary. So I'm going to get angle G4 in terms of x and y. So angle G4, because when I add it to angle G3, I'm going to get 180 degrees. These are adjacent angles on a straight line. It means that angle G4 will be the same as angle E. So without any waste of time, I'm just going to say angle G4 is equal to 180 degrees minus x minus y, and then I give a reason to say these are angles on a straight line. These are angles on a straight line. Now in this quadrilateral BHGF and BHGP, in that quadrilateral, what do I have? I have this angle here as 90 degrees. This one was given. This angle is 90 degrees. It's given when they said DA is perpendicular to FB. DA is perpendicular to FB, meaning where they meet, they form a 90-degree angle. So angle P2 is 90 degrees. So let's add the angles in that quadrilateral, knowing that the sum of angles in a quadrilateral, they add up to 360 degrees. So angle H1 plus angle G4, which is 180 degrees minus x minus y, plus 180 degrees minus x minus y, plus angle B, and then angle B is x plus y plus what? Plus angle P2, which is 90 degrees, plus 90 degrees. All these are equal to 360 degrees. We can see angles of a quadrilateral. And then the minus x will cancel with the positive x. The minus y will cancel with the positive y. 180 plus 90 will give us 270 degrees. So angle H1 plus 270 degrees will be equal to 360 degrees. I transpose 270 degrees. 360 subtract 270. I'm going to get that angle H1 is equal to 360 minus 270, which is 90 degrees. And that is how you prove that angle H1 is equal to 90 degrees, providing reasons. Like, share, comment, and subscribe.